Hey guys, this is Mr. H. Hey, I wanted to do a video for you on parent functions and family of functions. Some of you are moving a little faster than the rest of the class, which is fine. Um, but one of the things is I don't want you guys to be sitting around waiting, so I'd rather create a video and have you watch it and keep moving forward rather than sitting there and kind of wasting time. Um, but I'm going to acknowledge up front, videos are not the best way to teach, but in this case, it's a way for us to at least get you going, and then we can kind of circle back, and if there's any questions, kind of go through that. All right, um, so what we're talking about now is parent functions, family of functions. And I started with this image of the Jackson Five. This is the father. His name is Joe Jackson. This is Tito, Michael Jackson. This is Jackie Jackson, the oldest brother. Here's Jermaine, Marlon, Randy. Now, the reason I started with this is even though they don't all look alike, or they're not identical, you can tell that this is the parent and these are his sons. It's obvious to tell that they are related to each other, right? So even though they don't all look like Joe Jackson, you can see that they resemble Joe Jackson, and they definitely are. They also look alike. So that's why we consider this a family. Now, this idea, I want to use it for functions. You can look at different functions, and without knowing exactly what the equations are or seeing anything else, you should be able to say, oh, this is a linear function, this is a quadratic function, whatever, right? So we have 6 key functions for Algebra 1 that I want to cover. Now, I'm going to go through some of these kind of quickly, but these are the 6 that we definitely are going to see a lot in Algebra 1. The main one is linear functions. And the way you know you're dealing with linear functions is it's always going to be a straight line, right? It could be this way, it could be this way, but it's going to be a straight line. So as soon as you see a graph and it has a straight line, you should say, oh, that's a linear function. Now, here is the general equation format. It's going to be f of x equals x, or y equals x, or y equals 2x, but the highest exponent is going to be a 1. Now, you don't see the 1. They rarely put the 1, but that's the key distinguishing feature when you're looking at equations. If the highest exponent is a 1 on the variable, then you're usually dealing with a linear function. Now, from our previous, you should know that the domain is a negative infinity to a positive infinity. The range is a negative infinity to a positive infinity. That should be pretty obvious once you look at the graph. Here's a couple other features. Linear functions change by the same amount. And what I mean is you're adding the same amount every time, adding the same amount or number every time, right? So here's some key words that will indicate that you're dealing with a linear function. When it says fixed, when it says fixed rate of change, when it says constant rate of change, um, any of these words, as soon as you hear them, you should say, oh, this is a linear function. All right. When you're dealing with word problems, when you say it's changing by the same amount, it's changing by a fixed amount, changing by a constant rate, those words indicate linear function. The format of a linear function is generally y equals mx plus b. Now, this is the parent function. So this is the basis for all linear functions, just y equals x. But every linear function will have a slope. That's the number, that's the coefficient of the x term, and it'll have a y-intercept. So this is slope, and this is telling you how much the function is changing by. And b is the y-intercept. All right. And that's basically where it crosses the x-axis or y-axis. So those two things you need to know in order to come up with a linear function. Yeah, again, linear functions are straight lines. And another way of saying that is they change by the same amount. So the key is you add the same number every time you increase the x value by 1. So it's changing by adding the same number. All right, the next function is quadratic functions. Quadratics, the way I like to think of them, they're either going to be a u or an upside down u. Now, I call this a smile. This is a frown. And here is the general format. It's any function that has the highest exponent is a 2. So in this case, this is the parent function. The domain of the parent function is a negative infinity to a positive infinity. The range is going to be, this is where you draw, that's where you start from. So it's going to be 0 to infinity. Now, if the leading coefficient is positive, then your quadratic is going to look like a smile. If it's negative, it's going to look like a frown. So as soon as you see this one, you know that the leading coefficient is positive. It's actually a positive 1. Okay. Now, a couple things about the quadratics. They all have an axis of symmetry. And all that means is there's an imaginary line that goes down through the middle of the quadratic that splits it perfectly in half. All right. So the axis of symmetry. It also has what we call a vertex. The vertex is either going to be a minimum or a maximum. So if it's a smile, it has a minimum. If it's a frown, it has a maximum. The vertex is always on the axis of symmetry. So it's the minimum that's on the axis of symmetry. Okay. You can tell it's nonlinear. And the other key feature is if you look at a graph, it usually has 2 zeros. And all that means is there's 2 places where it crosses the x-axis. Okay, so 2 zeros. All right, let's keep it moving. Next one is exponential functions. Now, I'm going to use this one as our parent function, y equals 2 to the x power. The key for exponential functions is it's something that looks like it's starting slowly and then it takes off. That's the key for exponential functions. They grow really quickly. So the key when you're looking at an equation is if it has an exponent, the exponent is a variable. That usually means it's going to be an exponential function. So now, the domain for this one, I'm going to use y equals 2 to the x power. So this is going to be a negative infinity to a positive infinity. That's normal. Now here's the key. The range goes from 0 to a positive infinity. Now this parentheses is unintentional. The reason that it's parentheses is that exponentials have asymptotes. Remember, we talked about this. Please do not touch my asymptote. All right, that means there's a line. In this case, it's the x-axis. That's the line. This is the asymptote. Every exponential function has an asymptote. Yeah, the exponent is a variable. That's the key feature. Exponent is variable. Whenever you see an exponent that is a variable, then you're dealing with the exponential function. Exponential functions are the fastest growing functions by far. They are the fastest growing functions. And again, they're also nonlinear. Now, the difference between this and a linear function. Linear functions grow by adding the same amount, but exponentials grow by multiplying the same amount. So multiply by same number, same by same number. So in this case, we're everything by 2. We just keep multiplying by 2. So that's the key for exponential. A linear function, you would be adding by 2. That's the difference, okay? That's a really important idea. Adding versus multiplying. All right, let's go. Next is absolute value. Absolute value, basically, whenever you see these two bars around something, you know you're dealing with absolute value. Whenever you see a V, whether it's upside down or right side up, you're dealing with an absolute value function. It's very similar to a quadratic, except it has straight lines. Domain's the same, negative infinity to a positive infinity. The range starts at um, it's here. So it starts at 0, goes to a positive infinity. All right. Key features. Um, it has an axis of symmetry as well. It also has a vertex, just like the quadratic. The key about absolute values is any number that you put inside, it makes it positive. So the absolute value of -2 is 2. Absolute value of a -34 is 34. It makes everything positive. All right. Let's keep going. Next function is the square root function. I guess the key idea for this one is um, square root functions cannot have negative x values. So the domain starts at 0 and it goes to a positive infinity. The range is also 0 to a positive infinity. You cannot have negative inputs or x values. Same thing, negative inputs. So this is not allowed. You cannot take the square root of a -3. You cannot take the square root of -4. These are not allowed, at least not in Algebra 1. Um, so you cannot have negative inputs. The other thing that you should know about square roots is if you have a perfect square, like 25, when you take the square root of 25, you will get a integer. If it's not a perfect square, you would get a irrational number. We will talk more about irrational numbers later, but just suffice it to say, a perfect square, when you take the square root, you get an integer. Anything else, you get an irrational. Perfect squares, by the way, 1 times 1, that's a perfect square. 2 times 2, so 4 is a perfect square. 3 times 3, so 9 is a perfect square. 5 times 5, 25. That's a perfect square. So perfect squares, when they go inside the square root, you get an integer. Everything else, you get irrational. Okay, I think that's it for that. All right, so now we're moving on to the last one. This is the cubic function. It basically kind of looks like this little squirrely thing here. The key features when you look at the equation, highest exponent will be a 3. So y equals x to the third power. All right, so the domain is a negative infinity to a positive infinity. The range is also a negative infinity to a positive infinity. Key features. Uh, Basically, when you see the exponent, that tells you the number of zeros that it could have. So let me give you an example. If this is x and this is y, this one has 1, 2, 3 zeros. So this is I don't know exactly what the equation is, but I do know it's going to be a cubic function. So if it crosses 3 times, it's cubic. If it crosses 2 times, it's a quadratic. If it crosses only once, it's linear. Okay. So this one has cubic have maximum of 3 zeros. Quadratics can have a maximum of 2 zeros. All right. So I think that's it. One more thing. This is considered an odd function. 3 is an odd number. And all that means is that if you were to flip this way, did it change? No, it kind of, well, let me see. I'm gonna try to lock this. All right, here's the key. If you flip this way, does it change? Did it change? It didn't change. This is going to be symmetric about the origin. All right. We won't need that fact we won't need that in Algebra 1, but you will need something like that in Algebra 2. All right, so now let me summarize this. All right. here are the six key parent functions. So whenever you see a straight line, it doesn't matter what it looks like. It could be horizontal. It's going to be a linear function. You already know the domain and range. Other thing is that the highest exponent is 1. Now you will never see the 1, but you should know if I say y equals 2x, well, I'm dealing with a linear function. This one, quadratic, highest exponent is a 2. All right. If there's a negative number, it's going to be a frown. If it's a positive number, it's going to be a smile. So I know just looking at this function that the leading coefficient is going to be a positive number. Okay. What else? It also has an axis of symmetry and a vertex. The key is whenever you have exponent that's a variable, you're dealing with the exponential function. If you have something like this, a fraction, that means it's decreasing. If this number is greater than 1, it's increasing. All right. Also, the biggest feature that you should understand or know is that all exponential functions have asymptotes. All right. Every exponential function has an asymptote. All right. Let's go down here. Absolute value, same thing, very similar to quadratics. It has an axis of symmetry, it had a vertex. It just has straight lines instead of curved lines. Also, absolute value of any number is going to be positive. So absolute value of 44 is a positive 44. All right, square root function. Square root function, actually, this is really the one that has a fraction for an exponent. But we also just put it this way. But these are the same. All right, so key idea is you can't have a negative x value. That's not allowed. All right. So it has to start at 0 and it goes to the right. And then cubic function. Highest exponent is a 3. That means it could have a max of 3 zeros. And it's also symmetric. By the way, just quickly, this is called an even function, which means it's symmetric about the y-axis. This one is also symmetric, and it's also an even function. This is an odd function, which means it's symmetric about the origin. So if you were to flip this, it doesn't matter, they're going to look the same. All right. I think that's it. Guys, if you have any questions, let me know. But one of the things that you have to do is you have to start being able to recognize a function based on what the graph looks like or what the equation looks like. As soon as you see something, like if I said 5x to the second power, you should say, oh, that's going to be a quadratic and it's going to be a smile. If I had y equals 2 to the x power, you say, oh, that's going to be an exponential. If I have y equals 3x plus 4, you should say, oh, that's going to be a positive sloping linear function, a line. All right. That's the key. You got to be able to recognize your functions based on what the equations are or what the graphs look like. The next thing that we're going to talk about is how to recognize functions based on a table that you have. All right. I'm going to save that for another video, but what we're going to do right now is I'm going to go ahead and pause and post this. All right. Bye.